We left out this, and I think that your homework, if you already done so, this is what I'm looking for you guys to draw out, and then you guys to use the tool like Lucid or whichever tool you wanted. These are all going to be posted. You don't have to. And then also, some of you guys went above and beyond and make a very complex ER diagram, which is appreciated, but you guys don't need to necessarily do a lot. Like, it will be okay if you just have minimum, that's fine too. I just want to make sure that you guys prioritize everything and not get caught up with one homework, okay? But if you do have the time and want to make some practice and went above and beyond, that's totally fine. But I appreciate that. It's not a requirement. Okay, so let's refresh our memory. So last week, in addition to, so how do we get to this, right? We were trying to use a concept. We're telling a story of an application that we think of, and that was Airbnb. And then we describe Airbnb in a narrative, right? It's a short sentence and talk about the feature of Airbnb. And from there, we dissect the actors, actions, right? And then come up with attributes of actors. So then we eventually arrived here, right? So just so that we can pull up last time, the two of the tables for Airbnb. Okay, so let's do table for the property. Okay, and one for the host. Are you guys able to see? From this side? Okay. All right, so the property, I'm just gonna do address. And address and price. Let's do size for now. Keep it simple, because price could change, right? So let's just leave it as size for now. Host, I'll just do rating. We have the rating. And the other thing is, I will just say full name. Okay, so let's say MJCT5 for, and then NYC, I'll say New Jersey, size, I say 3,000 square, and then 12,000 square. Okay. All right, so we all remember this, right? We kind of end up here. We have another table, but that's fine. So we ended up here. So one thing that today I want to introduce is that in normal cases, and for any type of reference, when you do Excels or whatever, right? Oftentimes you can imagine for a bank, it would be very common that they have a field such as they will call it ID or property ID or host ID, right? So just so I understand, do you guys think that's pretty common? Like that makes sense? Yeah? All right, so can someone tell me that what normally what the ID field would do? What is it? What is the use of normally the ID field? Yes.
So let's say you wanted to reference posts within property,
Mm-hmm.
you could use the ID.
Oh, wait, I know where you're getting to. That's a little too ahead. That's fine. But just for the purpose of ID here, right? It's not really a attribute, or it's not really describing the entity, right? It's not really attributes. It is a column, it is the properties of this table, but it's not like address or size. Normally the ID is therefore so that you can easily identify a instance, right? It's almost like if I have a social security number, basically assuming everybody has a social security number, and that social security number should be uniquely identifying a person. All right, so if I want to have a system, let's say healthcare or whatever system, that supposedly has everybody's healthcare data, by the government or whatever, and I use the social security number, that I should be able to find not only the person, but also the record that that person have, right? For example, birthday or etc., right? And so that number is normally what we use as an ID, identifier. Yes, go ahead.
So I have a question. Is it used mainly for like security purposes?
ID?
Yeah, like in that case, like you just don't want to put your information or
Yeah, I
ID.
so so I think that you're raising a really good point. I think that it could be used for security purposes, but I don't think that for at least for the time being where we're for this lecture, it's not mainly for security. Okay, so let's say back in 20 years, 30 years ago, CUNY system, they actually use your social security when you register and go to school as the student ID. All right. In that case, now we don't, right? Now you don't even need to provide social security. Now you have an employee ID, which is like a randomized number, or it's a number that generated for you, right? Is to hide your actual like regular information. It is for in that case, it is for social security. It is some database might create a new set of identifier for their own purposes so that they don't have to always display these like very private information in that case. Okay. But for our case here, we're just very simple. We're just talking about an ID field that is in addition to all the other attributes that describe an entity, right? In order for us to uniquely identify a row, right? If I put 2 here, right? In the future, if I say I want a property 2, then we should be able to find the record of that property 2 being the address in Jersey, etc. Right? So we're also going to do it here. Okay, so that is very quite simple. We're just letting that sit in so that I can build up on the context of this course today. Now, one thing we talk about the banking system, airline system, the first use case. Okay, so this table over here, right? It's just a simple table that PowerPoint created for. But honestly, if you downloaded MySQL, if you downloaded Microsoft or whatever, there's not that much different, right? The actual table that display data, and we're going to learn about SQL, but even without using SQL, normally a client of a database management system, such as MySQL client or Oracle client or whatever, these data is exactly displayed in the table on the front on their GUI. What is a GUI? Does anybody not know what a GUI? User interface. Okay, GUI with a G. The G stand for graphic. So it's just graphical user interface. But UI is the same thing. What I'm saying is that the client, if you're using the client, you could go on and click on buttons and drag down and then tell the database to show you the table of property or show you the table of host. It will look just like this, basically, or just like that, basically in the table format, right? But we do want to learn about using query later on. That will be okay. But just so we know that, if you haven't already downloaded MySQL, this is kind of how it will look. All right, well, this is where we're going to get to at some point. But before we get there today, some more that we need to learn today is okay, relational algebra. If you remember last week, I did mention that relational algebra predominantly are being taught still in very deep length for most of database class. But they are something that useful, which I'm going to go through today. There's a couple of usefulness parts of relational algebra that I'll go through today. But the rest, you will be able to refer to the textbook. In my opinion, I haven't used it for 13 years ever in the career. So it's not something that I think that it's really practical for today's database system. But the good things is I will pick the ones that will be useful and it's also sufficient for you to learn. First thing is to represent a table, we can use relational algebra because it's actually a very simplified way to let us know how we are reference to a table. And the way to do that is, for example, property, right? Property. Table name, and then ID, address, size. It's easier than writing out a table and then drawing out and everything, right? This tells you that I am now talking about a property that has the ID, address, and size. I'm sorry, table that has these three properties. Simple, right? Okay, can we use that? That's fine. We can keep that. We can keep the good part of relational algebra here. Post. ID. Full name. Just applying two tables as an example. That clear? This is going to be something that we will use going forward to state as a host table or property variable and whatever property that might be in there. Okay? Simple enough. So far, so good. All right. The second thing that we want to talk about, and then today we're going to use only a little bit of it. We will at the very end of semester circle back on this topic. But so far we just have to learn about this. In algebra, in mathematics, we learn about logics, right? We learn about equation or logic, right? Stuff like that. So what does this mean? Can anybody tell me? Yes.
A implies B.
Yes. So A implies B, right? Simply, that's correct. Or in other words, if A, then B. Right? Okay. Remember this carefully, because if A, then B in normal algebra, that's the case. But in relational algebra, this means that A is a functional dependent of B. B is functional dependent on A. Okay, in relational database, you just have to remember, in addition to how you say if A, then B, translate to relational algebra, A is a functional dependent of B. B is a functionally dependent on A. Okay? Okay. So what does that mean? Let's come back and look at this. Okay. It means that there will in a table, right? There's oftentimes, including ID, which what we just did, or sometimes like full name plus date of birth is good enough information for you to be able to retrieve that entire instance. Okay, so A is the functional dependent, meaning like the identifier or the information you need in order to get its non-identifier attributes. Okay, so for example, A in this case A is our ID. Okay, relational database is saying that A with the ID, you should be able to find out what B, anything that is not an ID, their values. But B cannot go back to A. Okay? A can go to B. ID or identifier, therefore non-identifier. That this direction is fine, not the other way around. Okay, for example, okay, address is non-identifier. Sometimes it could be identifier, that's fine. But let's say in this case, just the city, right? The city can be redundant, right? It could be duplicated. It could happen multiple times. Can I use NYC enough to tell me what A, in this case, the ID is? No, right? But if I do have the ID, I should be able to track what the city is. You see that direction now? A to B, yes. B to A, no. Okay, now let's use an example here. Okay, so ID and full name. Okay, full name, like first name and last name. In this case, I just be lazy and I put it just in one column. Full name sometimes is used as a identifier, in this case, functional dependent, right? Because I should be, even though, okay, for example, maybe there's a column, date of birth, right? Date of birth can be shared, it's non-identifier. It could be shared across by a lot of people can have the same birthday. But using full name, first name, most cases, let's say if it's a small set of hosts, you should be able to find out their date of birth, but not vice versa, right? But the caveat here is first name, last name. When it gets big, like a school, for example, or like Social Security, like the Social Security Administration, then obviously it's not feasible, right? Because people can have multiple, there could be multiple John Smith and, you know, et cetera, right? So that will be another example where A is a functional dependent, which is the full name in here, to date of birth, star rating, etc. Because full name itself is almost good enough to be identifier. Then ID, obviously, you know, similar to here. Okay? So these two, fundamentally, the first part, we're going to continue using every almost the class going forward for simple sake. This AB, just remember this because now we need to talk about keys. But we are going to come back here when we talk about normalizations again. Okay? All right, so keys. Without knowing database keys, without knowing relational database, anything about keys, what does key do? Or what is key for data for programming language? I can give you a hint. Data structure. There's a place that mentioned keys.
Key is an identifier
Of what?
of a value.
Of a value, which is what data structure? Key value. Yes.
Hash map.
Hash map or hash table, whatever, anything that has the hash, right? Okay, sure. So similarly, key has that aspect in database, where basically thinking about keys is normally used to identify values. However, you have an identifier here for database, right? It doesn't mean that they are keys. Okay, you can create a table, right? Later on, we're going to learn about actually how to create a table. We're still talking about very high level. This is how relational database store data, right? Two-dimensional tabular format, right? Let's review something together before the database. Okay, so find a good place. All right, we have database. Actually, let me put relation. Okay, so R, D, B, okay? Then the next step, this unit, the next is what? Table, right? This is just to refresh our memory. What does table also known as? Entity, yes. And what else? Huh? Actor, yes. That's fine. Okay, and
Nouns.
nouns, yeah, okay, sure.
Schema.
Schema, yes. Um. They also are similar to class. What else is there? Entity. Okay, let's just leave it for now. I think there's definitely more. I can't.
Relations.
Oh, yes, very much. Relations. Relation, right? Okay. Columns. What about columns?
Attributes.
Attributes. Yes, thank you. And
Properties.
properties. And anything else? No.
Classifications.
Classification, that's fine, yes. Okay, what about sorry, it's just an issue with like, sorry. Right. Rows,
Entries.
entries, very good.
Tuple.
Tuple, very good. You study, you read the textbook, didn't you? Chapter 1, yes, very good. What else?
Instances.
Instances, yes.
Data.
Data is what's within them. Right, that's fine. Okay, we'll just leave it. If I think of something, I will come back. Okay, so where was I? So when you have a table, okay, and when you're creating a table or when you're just trying to view a table, you will see that a table can simply have no keys. Every attribute just stored almost like an Excel spreadsheet. The top row is just the name of all the different attributes. It could simply just like a flat table. I mean, the word flat is not really, doesn't mean anything, but this is how I see it. It's just like a regular table, right? You can still have ID in there to help make it identifying and everything. But for database, key is used just like how we're using for, Python code, C++ or Java, whatever. It's used to retrieve certain value and then used in a similar fashions as hash tables. But you need to actually specifically declare them. You need to specifically, the way that we call it is we adding the key to a table or making a column a key or making multiple column a key. Basically, you can't, it's not automatically you don't automatically make a column a key. You need to actually specify what columns you would like to make a key. Okay? So in order to do that, first of all, you need to specifically declare a key. And secondly, databases, relational database. Remember what I talked about, how the banking use case, we want to be very accurate. We want it to be very private. We want to be secure, all that stuff, right? Obviously, if you want your servers to be providing all these features, you need to adhere to a lot of rules, right? So it's a both way relationship, right? It's mutual. So there is a terminology called constraint. Constraint. Where can I? Okay. Okay. There's certain constraint you need to follow if you want to make a column key. Okay. Now, the first key, some of you already know that I'm going to introduce today. The first key is called primary key. Okay? Primary key is one of the most popular and it's a very common knowledge of database, relational database. Okay? The use of primary keys predominantly is very similar to, you can think of a key in a hash table, right? It's used as an identifier and everything. But I did mention that this ID itself already, if we create it like this, it already follows these like A to B relationship and all that stuff. Why do we need to why do we need to call it a key? First reason, if you're making a column key, you need to follow certain constraint. Constraint number one, no duplicates. Okay, if you make a certain column key for your table, the first thing it will do is that going forward, when you're adding a new row, they will always check that your ID field automatically, if it's duplicate, if there's two, you're trying to populate another row, and the ID is 2 again. When there's another 2, it's going to throw an error. It's not going to be created. You see? So constrained, in other words, is guardrail, right? So why do you need the ID to primary key? That's one of the reasons. Because it gives you mutually using the constraint, it gives you a guardrail. Never duplicates. Primary keys, never ever. Number one. Second reason, when you have a primary key, later on, we'll be talking about relationship. The primary key is the key to, well, again, key, it is the connectors between tables. We'll leave it for slightly later. We'll come back to this. Thirdly, a primary key for the table, when you create one, or when there's a table already, and then you decided, like for example, if I already went ahead and then when I create this table, and this is totally fine. When I create this table, I go ahead and then just say, do it like this, and then without adding any key. That's totally fine, number one. But I can also choose now, after I have all these values, now I want to make the ID key. Yes, I can decide to do that later on. I don't have to always do that at the creation. I can regret and then come back. I can even remove it, which is fine, okay? But just so you know, when you have primary key at creation, or later on when you come back to do the table and do the primary keys, what primary keys will do, okay, is that it will make the column that you made into primary key indexed. Anybody know what this concept of index means? It's a reserved terminology for relationship database, relational database, yes.
It's like a position in a data structure.
Pretty much it, yes. Index means that you essentially create another index hash map. And you automatically, the value, which is the ID column, you automatically make, number one, you make finding this ID a lot easier because now it's tracking on the hash table. So that's the first thing that index does. Second, there's another thing that when it's indexed, what database will immediately do on the backend or going forward will do. The database will look at this index table of this index hash of your table and sort by every single index columns. Okay, so in this case, primary key is index. So that means the database, even though you don't see it, it will go back and start positioning based on the number, numerical number, and sort it. The large number actually comes first, though. The larger number will come first. So that's actually two things that's changing the table when you're adding the index. Now, if you create a table with primary keys, it will automatically make it into an index. So your table going forward, even when you're adding the first row, it's always going to be sorted, meaning like the positions of every row in your table in the database when it's being stored, it's always going to be actually sorted following the primary key. Okay, so two things, let me just reiterate what the index do. Okay, first thing is that column that you make into primary keys, which automatically get indexed, is now on this hash table. So that looking up will be much easier. Let me ask you why. Why do you think that database want to do that? Like, why do you think the index functions of the database want to make primary key automatically indexed? Why? Yes.
It makes searching much quicker.
Yes. And why do you?
Because
What?
if it's already sorted, then you can use binary search. That's the
Yes.
fastest.
And in other words, it's also likely because this is telling you that this primary keys is probably, in most cases, a column that is heavily searched or heavily used, right? Okay, hash tables. What is the most heavily used to look up value? The key column, your keys, right? So that means, in other words, here, the reason that it's putting into a hash table so that it can be searched fast, that means that column automatically in the database table is assumed to be the most searched one. What is the most searched? If I have an A, if I look up A, I would know B. So I can use the A the most to find information quickly, right? Later on, when we're talking about actually writing SQL, if you already read the textbook, you should know that there's a where clause in the bottom that does the filtering. That's the place when you're doing a lot of searching for. Like when you're doing filter, you're meeting a condition, for example, ID equal to 3. When you do ID equal to 3, that is essentially a search, a match, right? It's being done presumptionally, doing the most. Okay, now I'm gonna jump ahead and say to you that primary keys are automatically indexed. Automatically. So the database also give another special name to these primary keys. And only primary key gets these names, and which is kind of redundant. I don't know why they do that, but I'm gonna call it. It's called clustered index. Cluster index. Only the primary keys are in the cluster. It's really stupid. terminology. But the reason I'm bringing this up to you is that there is non-cluster indexes. What do you think, guys think one non-cluster indexes mean? If primary keys is cluster index, what are non-cluster index? Any guess? Yes,
Not sorted?
no. It just means all the other column that you make it into an index or add an index to, that is not a primary keys. It's simply that, all the non-key tags that you manually add into the index. Because for example, I could say, I can make primary keys on ID, right? But maybe I also want, maybe I realize that full name search for a host is also very important. For example, maybe everybody guest wants to use the same host, so they look up the host name again. So I want to add an index to full name. I can do that later on too, right? It just will say full name. And full name is not primary key, so it's non-cluster. That's simple as that. It's very simple logic. There's no really like that much complexity in it. It's just primary keys are automatically indexed. So they're calling it clustered index. So all the ones that you do manually later on, because you want to get search faster because you find out searching and joining happens a lot on that column. Those are what you do later, adding an index to, right? It's not automatic. You have to say, I want to add index to this. Those are non-cluster. They're also sorted. They're sorted after the primary key. Okay? Depends on when you add it onto it. All right? And the purpose of doing that is also so that it's often used, often searched, and then you want to get result faster. You want to turn up the speed a little bit. Okay? All right. We'll come back to talk about this again, I think, in lecture also towards the end. But I always spend a lot of time on here because this come up in interview all the time. Okay? For data science or database or whatever designs. Okay. All right. So now that we learned about primary keys, we learned that there's no duplicates once I'm making primary keys. There's no relationship. I mean, it's the source of relationship. We'll come back to that. It's automated index. The fourth thing is there can be only one. Okay. One table can only have one primary key. Okay? All right. Now, however, let me tell you that all these things are the constraints, so you must follow these. The next thing I want to talk about is not violating any of these, but I want you guys to know another two keys, combo and candidate. Combo keys and candidate keys. Combo keys are also known as combination keys. Okay? Now, even today when you, let's say at work, and you open some database that has been out there for a long time, somebody else created it, and it's been used for a long time. Back in the days, there's this thinking that database is always going to grow bigger, which is true. It's always going to grow bigger. And then later on, some newcomer join, going to add more columns so that it itself is more information. It's sometimes there's records of like a table with like maybe 200 columns. That's all possible. So back in the days, there are people who are still hang on to the idea where like, okay, let's keep column less. Let's keep less columns, so it's easier to manageable. So they don't want to go ahead and additionally create an extra column called ID and make a primary keys out of a new column. They want to go and improvise. I'm not saying it's a bad thing. It's not, these days, it's not really recommended to do that anymore, but that's happened, right? For example, I might not necessarily, like I said before, I might not necessarily need the ID field here. I might not, right? Maybe an alternative before was that I have first, last, and then last for social, okay, and then the rating. Okay. Did I mention that 20 years ago, this is a very common candidate to use as a primary key? Like the combinations of these two. Okay, but listen carefully. You can make first name and last name 2 columns, a primary key. You can make 2 columns, a primary key. This can be a primary key, but it will also be known, it has a different name. It's just like saying like I can give birth to child or twins or children, right? Like at once. So when you have more than one column as a primary key, it's also known as combination key. That's what the combination is for. Very simple, very straightforward logic. A combination key is still a primary key. It just, instead of singular, it just have multiple columns. We give a name, it's combination key. But it's regardless, still primary key, okay? We're just using that to differentiate a key that we normally pick, normally creative, identify numbers like, long digit and stuff like that. In order to do primary key, we go improvise and find some double or triple size column. That's what combination keys is for. Now, candidate keys is slightly different. Candidate keys means anything that potentially could be a key, can potentially be a primary key. Anything that could potentially be used as a primary key, but not necessarily a primary key. For example, like I mentioned, if I define the ID as a PK, it itself, even though ID is a PK already, it itself is a candidate key. Because it is a primary key candidate, even though I chose it. I'm talking about, does it have what it takes to be a primary key? Yes. So ID does. Last name, first name, last name combination is also a candidate, a primary key. So it's called candidate key. ID and first and last name, 3 things combined. Is that a candidate key? It is. It's possibly can be used as a candidate, even though it's redundant, but it is. Altogether. Last word, social plus first name and last name. It could also be, right? Or even last name and social security. That could also be. Anything that could have been used as a primary key is called candidate keys. Okay? That's what a candidate keys means. Combo keys means primary keys, already the primary keys, but instead of singular column, it's made up on multiple columns. Primary keys, oh, we know that. So these are just reserved terminologies for relational database that we need to know now that we will use later. But these are the, yes.
Would they have the same constraints as the primary key?
Well, combo keys is literally, it's just exactly the same as primary key.
Yeah, but like, let's say first name and last name, you could have duplicates.
No, but the combinations of it cannot.
Well, John Smith, John Smith.
Yeah.
And do you have
That will be a duplicate, yes.
so do you have the constraints when entering
Yeah. If your combo keys, which is you made it into a primary keys using first name and last name, yes, if the second person come in with the exact same spelling of the first and last name, the database would not have it recorded. It would not be allowed to submit the entry. Yes. So that's why that whatever has happened a long time ago now beginning to fail, right? So it's still recommend to have your system, all the database these days, you can create a column for identifier like a newly purposeful column, like an ID column, right? And you can choose to use the database itself to auto-generate numbers so that it always just like add one or add two or add like a randomly generated number or add using the date time and translate it to a number so that it never repeats. You can do that, or you can use your own coding language, and when you're inserting a new record, use like Python to generate like a brand new number that's never been used before. Something like that. So that's always nowadays more recommended. But given that's the case, for design, ID itself, you're creating a new column is recommended. There's going to be also more explanation that we're coming up later to talk about normalization. But right now, we're just talking about what are the keys and the definitions of all these different terminology. But combo follows primary keys regardless. Okay? And candidate keys is just potentially could be a candidate, but they didn't make it to your primary keys yet. All right, so now, remember we said that we're going to come back and talk about this relationship? All right, so this is the time. Now we know about primary keys. Remember last week, we said that those verbs that we draw on ER diagram and become in the diamond shape and stuff like that, those things we want to hang on to that, and then we'll come back to do to represent that in the actual table here. Okay, so can someone tells me if someone already have experience or someone who read the chapter ahead, what is the technique of making a permanent relationship of two tables in relational database? What is the most, yes?
So we basically put IDs as a core of other things.
Yeah. Okay, I want you guys to think about something that will be a quite similar idea. Does anybody here not know object-oriented programming? Is anybody here doesn't know? Okay. When you have a class and you want to reference to another, inside that class, you want to reference to another class. Like for example, I am person, right? And no, actually I have a car as a class. And in the class, I have tire, another class, right? And that other class of a tire, that could be a Nissan or like could be a Michelin tire or whatever. The car itself could be what, like a Toyota or like Honda or whatever, right? How do you get to reference your car? With your car, how do you reference the tire? Yeah. Yeah, you'll create an instance, right? You'll add a local instance or you'll declare instance and you instantiate it. Right? When you're doing instantiations, you need to put the tire ID or the car maker or whatever, right? It's very similar, but rather than putting the entire object, instantiate the entire object, in database, you basically just have to reference the ID of the tire. Basically, that's the similar concept. So, in this case, I would like to draw it over here, but we don't have space, so I'm just going to draw it over here. Excuse me for that. I have a HID. HID. That's equivalent or short for host ID. Okay? And that ID is basically referencing to this primary key. Right? And so I have 2 here and have 1 here. Can someone try to tell me what does this mean now? This property. This property. With a 1. Tell me property 2, address in New Jersey, 2,000 square feet. Who is the host of this address, of this property? Yes,
Is it MJ?
it is MJ. Does anybody kind of get it?
You repeat that?
I'm getting a pointer, basically. I'm getting a reference in the host. In the host, I'm sorry, this is property. In the property, I am storing the key of host. You see this? Property, right? I have a host. I have a host ID here that I just created. Right? It's a column. It is referencing to primary keys of host table, right? So this primary key here, the value is 1. What does that mean? Is MJ, right? So in this case, I'll read that property 2 owner or host is 1. Therefore, it's MJ, right? Because this is A, this is B, right? By knowing 1, I know the B, right? By knowing 1, host number 1, I know that its full name is MJ, right? So now, this 2 table is connected. Okay. Yes.
Does the new column that you just created become a new primary key, or is?
No, this is the next step. We're getting there. Okay. So obviously, database is not going to just not come up with a very special, unique name or constraint by doing this, right? Everything that you get from the database and then do something permanently, there's always another constraint. We call it flooring constraints. Under flooring constraint, the column that we use to reference from your original table, reference table, we make this column a foreign key. Okay. So what is a foreign key? Basically, foreign keys is that it is the key, but from another table, right? So that therefore is foreign. It's not your primary key, it is someone else's primary key, right? I'm referencing it. Therefore, there's a name that, therefore, the terminology foreign. But it's basically just saying that this column is foreign to them. It's actually this column here, these ID, this key doesn't do any identification because it's a foreign. It doesn't identify any other B's in here. It identified the B's in its original table. Okay, now the constraint of foreign keys. Okay, so just like when you're creating a table and then you're adding you want to declare the primary key of a table, right? So once you do that and you create that table, and then you're trying to insert a number in the primary key that already exists, the system is gonna throw an error. It's not going to work, right? Just like that. Now, when you are populating, when you're populating a row in this table that has a foreign key, you cannot populate it like this, for example. You cannot do something like this. You cannot have a foreign keys value that does not exist in your primary table, in your primary keys only table. This constraint is going to be automatically checked by the database. Basically, if today when you're inserting this third record, right, and then you're saying the owner is number 4, but there is no number 4 in this table yet. That you are flooring. So this is not allowed. This would automatically get errored out. It will not work. It's not going to be saved in the record. So that's the first thing. So if you're flooring you have a foreign keys, the value must have already been existing in the primary table. Okay, so then you're asking me like, I don't understand. So how would I be able to add, like, what would be the order of these two tables as far as relationship wise? Okay, so given that there's primary keys and foreign keys concept that I just explained to you, when you're creating a database, you will probably do is step 1 is to create the table of host with primary keys. Okay, you'll probably do that. This is your creation, right? Then you'll probably create a property table. Primary keys is the ID and a column called HID foreign ID from. This is just steps. I mean, they are not codes yet. Like I will show you how to code this out later on SQL, but this will be the step. And third, your insert or populate. Host. It's just a simple step. Now you'll ask me, now how would I know the host ID? Do you have that question? Like if I go through each step and then I insert the host or whatever generated, how would I know the host ID? Yeah.
You would select the primary key and then check what the host is.
Yeah. So basically, given an information here, right? Like given the property information, you'll probably have the owner name and stuff like that, right? You'll probably use something that you have on your records of the property. Then you look up this table to find the ID. Once you have the ID, then you use that to populate the property record. So you will use the ID, right? You use the name, find the name, you look up by the name, and then find the ID, so that the ID is definitely there. Then you use the ID to do the population, right? And that way, these steps will allow you to make sure that these constraints are properly followed, You're following all the constraints for foreign and pirate. Yes, do you have a question?
Yeah, can you repeat how did you find the ID for the phone?
So we haven't talked about query yet, but in the pseudocode, just think about encoding. You would say from this tape, from this entity or from this class, right? Or from all the array, from this array, or from the array list, look for from the array list of hosts, look for the host has the name of MJ. Return the ID. Basically similar. That's a pseudocode that we later on going to learn how to write in SQL, right? Does that make sense?
Yeah.
So you'll get the ID. And that way, with that ID, you can bonify and have that stored in the table that's foreign key. Right? So you'll have a matching number. Does that make sense? Yeah. All right. Any questions before we move on?
So you said you would look up the name and then
You will look up, you can look up, name is an example, like most, it's basically. We are storing, if I'm gonna try to explain, I don't know if this is going to answer your question, but I'm gonna try to explain in different words, okay? This is a database that we not only want to retrieve information, right? We're gonna assume that we're storing information in, right? And given that we want to store database in a certain design so that there's eliminations of redundancy. Given that that's our goal, that's basically our goal, so that there's not going to be too much records restored repeatedly. For example, can I have two houses by the same owner? I can, right? There could be two houses by the same host. That's fine. That's totally fine. This is not primary keys to them, right? This is the foreign keys, right? But if I only have one table, that is the property, and then the host will only be, I would have to write the full name again and then start reading again all the other address information again. But in this case, I'm only storing a pointer. Isn't that a lot storage saving in this case? All right. So that is the purpose of storing relational database, right? Because we are using essentially relationship to bind data, but we want to store it in a separate table so that they're stored efficiently. So assuming you have property information, and that property information will give you initially, like as a flat file or whatever, give you the host name, right? You will look up the host by the name and ask to return the ID. You find this row first. If you do in your coding, for example, you have an array list. Think about this as an array list of hosts. And then you're looking up search host dot full name equal to MJ. Using Java, well, I don't know Python very well, but like imagine like array list search, right? And you're given the property equal to what? Then once you find the object, dot ID. Right? You essentially, we're talking about pseudocode in programming language, but SQL has that as well.
my question was like,
Oh.
if like you said, you're searching by the name, right?
Yeah.
Like the whole point of the ID is that if there are people with the same name, like we can separate them. So like if there are, like this is like an edge case, like there are multiple people who have like same name and like same other things.
Mhm.
How do you differentiate between them?
Yeah, that's a really good question. So, I mean, first of all, that definitely could happen, right? I mean, like you can't tell me that on Zillow, there's not two John Smith, like that one lives in Dallas and one lives in maybe Jersey, right? That's possible. So that if that was the case, then maybe like you would just, very simple, you just have to make multiple lookup properties. So in addition to full name, maybe you have to look up the date of birth, or maybe look at like year the property was purchased. Like you need to find more information in order to add up almost like a candidate keys in order to reverse look up the ID. and then store it that way. Yeah.
So I have a question,
Yeah.
do we, I don't know if that gonna make sense, do we actually make the relationship between the two table? Or it can be done like automatically by the database?
No, so when you do this, like when you're inserting the data, and then if you do the HID like this, automatic, like, you know, and then if you make sure that you did what I just told you, like, you know, reverse lookup for the ID and store it this way, they are unofficially, but they are sort of visually, you know that they are related. But the problem here is that once the table gets big, you don't have,
Can do it.
no, once the table gets big, it's hard to maintain its cleanness, like, or like, let's say if a host is deleted, the record is deleted, right? If the record is deleted, for example, when you have these foreign keys constrained, the database is going to warn you before this row is deleted. Because it needs to make sure that a foreign keys has a primary key in the original table. So you can, there is unofficial way, like, just like two Excel spreadsheet, right? You can always still reference by looking at, okay, the ID of this sheet and the other column of other sheets looks like that's what they're talking about, the same thing. You could, but then you're losing some automatically checks and balance, the constraints like I mentioned about that the relational database provides you. For example, do you need a primary keys to make these identifier this table? You can make the ID by just creating a column, like I mentioned, it's just a flat sheet, right? But making that into primary keys, the benefit is it will check that if there's ever a duplicate, it's going to throw an error. It's just these things that by default, the constraint and these features that database give you to make sure that your database is it's continuously be checks and balance and healthy. And if there is any type of abnormal or like deletions that's associating with the scoring constraint, it's going to let you know. For example, if there's two here, and this host, someone have access to the database is accidentally about to delete this. That would be a big problem, right? Because assuming Airbnb has billions of rows, and now all of a sudden, if I want to look up on this property and I have a 2, but there's no matching 2 in the host table, that would be a big problem because there's nobody that is referencing to. But if you have the foreign constraint, the database is going to not allow you to do this until you clear up here as well. You know what I'm saying? They will make sure that there is some like gatekeeping and balance prevent you from doing this. Yeah. Any other questions? Yes.
Will this also make sense to kind of like post both of the HIDs for each other in order to like easier access? For example, there will be HID that points from like table 1 to table 2.
Oh, you mean like for the PID, you mean?
Yeah,
Property ID.
yeah, like that.
Well, in some case, you could do that. There's not going to be any errors for you to do that. But in this case, then you're making it almost like, I'm trying to think. I'll tell you that one of the things that it wouldn't work. Okay. Normally, the place that's going to have the foreign keys, okay, we're kind of jumping ahead because I don't have to tell you this because this will be a little more advanced that we're going to talk about something again, but just because you mentioned, normally, the place that you'll decide to have the other person's reference value, in this case, the table that you want to have the foreign keys, will be the place where you read one-to-many relationship. I earlier on mentioned there's relationship. I was going to stop you there, but there is a concept of many to many, one to many relationship. For example, as I mentioned, a host an owner can have multiple property or house, right? And let's assume a host can have multiple house and a house have just one legal host. Let's put it this way. Imagine this. Remember I said, for example, there's two twice, right? So CT has two houses. Okay, so CD has two houses, right? CT. Then what would you put here?
Is it possible to put two instead of?
Right, in this case, you will either have to put like an array list or whatever, or like two number, like house, 1 and 3, right? Or like you will create another PID 2, right? And then later on in this semester, you will learn that this is not a good practice. You understand what I'm saying? So in best practices, normally you will look for the one that you will read that has a many possibility, like one to many. Then the many part is the part that you will receive that foreign key. Okay? Later on, when we learn about, it will be more clear to you. This is all about database design, but it will be more clear to you when you're learning about normalization. Okay. I'll take a 5 minutes quick break so I can recharge my phone. We'll come back and then we're gonna jump into SQL.